Okay, here we go then. We have some hints for homework sheet 3. First question is all about when does a quadratic have equal roots. Now we know that the condition for that is that b squared minus 4ac has to equal 0. So from our quadratic in the question, identify what a is, identify what b is, identify what c is, and then just plug them into those formulas. Just in case anybody out there is not too sure, we had x squared plus q minus 3x plus 1 equals 0. So 1x squared would tell you the a, the q minus the 3 would tell you the b, and the plus 1 would tell you the c. So we plug them into that formula. At some point you're going to have to factorise, guys, and then you should get two answers, q equals and q equals. Question 2. So, right. So, question 2. Find where the curve x cubed plus 3x squared minus 4 cuts the y-axis, the x-axis. So it cuts the x-axis when it's equal to 0. So the only way to solve this type of equation is to do our synthetic division. So put your coefficients in, 1, 3, now is it 3x squared. There are no x's, negative 4. So you have to pick numbers so that when we go through our process, we end up with 0 here. That should eventually lead us to 3 brackets, and because this one does equal 0, we work out what the 3 x values are. Second question, where does, oh a minute, what's that? Question, a wee second. Now we can move on to question 3. Find the centre and radius of the circle. Well, that should be easy to get from the actual question. You know what we do with the 8 to go in there. You know what we do with the negative 2 to go in there. And you know the formula for the radius is the square root of g squared plus f squared, take away c. Now the second part of the question is not just quite as bad as it looks. Here we've got a circle. Right, we know its centre. We know there's a point on the outside here. And what the question's asking you is what's the length of the tangent. So in other words, how long is that line there? Well, what do we know? We know the radius. How do we know that? Because we've got that from up here. So we can put that in for the radius. We also can find what that red line is, because that's just the distance from the centre, this point here, to the point that the question gave us as 2, 4. So we can use the distance formula to work out that distance. Then all we need to do is a wee bit of Pythagoras work, because we know there's a right angle in there, to find out what x is. Right guys, it looks like I've... Question 4, some differentiating. I'm not going to talk about the first one because that's easy for you. The second one, we need to get that into a differentiable form. So that means that x is going to have to jump up the top. So it's going to become 1/4 x to the power negative 1. Now you can differentiate. The third one, we're just going to do our FOIL to remove the brackets, and then we're going to differentiate. And then number 4, we need to get this into a differentiable form. Because it's got a root sign, it means the power is a fraction. On the bottom of the fraction is a square root, so we put a 2. On the top of the fraction is the power 3. Okay, so we can now do our dy by dx. Question 5. find the value which makes this a tangent. So we've got a straight line, we've got a circle, we need to solve them simultaneously, so that just means plug your straight line in. So you've got x squared plus x plus a squared, bring the 2 over, that's the secret here, make it equal to 0. Tidy all that up and it just becomes the same as the first question. Equal roots. What's A? What's B? What's C? And then plug them into b squared minus 4ac equals 0. Okay, so it starts off as a different question, but then eventually just becomes the same as the first question. Question 6. Now, we know the recurrence relation is un plus 1 equals aun plus b. So we need to find what's the value of a, what's the value of b. Okay, now we did those ones before, but it's been a few months ago. We have to end up with simultaneous equations. So how do we generate those simultaneous equations? Is that we plug in these values. So we start from the end and work towards the front. So 3 equals A9 add B. And then we move on to the middle one and the first one. So start with the 9 equals A33 plus B. Tidy them up into simultaneous equations, work them out, and you'll have what A equals and what B equals. Number 7. Show that the quadrilateral with vertices, so I've drawn a wee picture for you, remember pictures always help. Show that's a kite. So the big question you're asking yourself, I know you are, is what on earth defines a kite? What makes a quadrilateral into a kite? And if you can think back to your first year work 4 years ago, at some point you would have been told that a kite is a shape where the diagonals cross at 90 degrees. So in other words, they're perpendicular. So if you can work out the gradient of AC, if you can work out the gradient of BD, and then times them together to get -1, if you can show that that is the case, then it means you've got a kite shape. Now look at the wording for part B. It says write down. So that means shouldn't be doing too much work. Okay, so how on earth are we going to find this point here? Well, again, looking at the picture, we know that kites are symmetrical. Okay, so this distance here is going to be the same as this distance here. So in other words, if that's the same as that distance, then this point in the middle here, that is the midpoint. So part B is just a really fancy way of saying what's the midpoint. Okay, so it's not as hard as you think, guys. And that's us.